I'll want to upload grades like after we finish the semester. So it's probably going to be that week of the, let's see if I got my calendar here. It's probably going to be the week of the 18th is when I'll probably want to upload the grades. So try to get all your labs in. This last lab is important because it's weighted heavier than the other ones. And let's see, did somebody else join that needs permission? Speak up if you just joined and you want to record. I think I got everybody who's online right now. Okay, yeah, try to get all your labs in. Like, when are finals over? I forget.
I believe it's the 16th.
Okay, yeah. Try to get all your labs uploaded at least by the end of that weekend, and then the 18th, 19th, I'll probably try to finish the grading and upload the grades. Okay. So 2 weeks ago we simulated, and I didn't record my simulated values, so I'm kind of struggling here to get my circuit up and working again. But oh, let's see, before we go to that, let's see, there's a note on the chat. Okay, that's Jerusalem. There you are. Okay, so what I was saying, I'm probably going to try to upload the grades around the 18th or 19th, and try to get your labs, if you're behind, try to get them in at least by the weekend, the 16th, 17th. I'll probably be grading the final lab report. Oh, and on this final lab report, so you all have your design specs. And so one thing I expect to see is a summary with the design specs, and then you want to show the circuit that you built and you simulated and then you built, and compare whatever, or do some creative writing as to why the values changed from one to the other. And then I want to see a comparison of like what the performance was when you tested it versus what your design spec, and be able to report, okay, I met my design spec. So, when I go to grade, I'm going to look for the simulations. I'm going to look for test data, for the oscilloscope plots, and then a summary table. Okay, so right now I got mine going, but it's not looking so great. And again, what I did is I came in, I didn't really look at that closely. Where's that Word document? This is the one that's on Moodle. So this is the circuit I'm building, but I don't think I made the modifications on this copy here for 5 volts. I thought I had a 5-volt version on Moodle, but I think I have to go through and redo this real quick to get this thing running properly. So bear with me. Oh, does anybody have any questions about the simulations or the calculations from last week? Okay, let me see if I can get the right values here for 5 volts. Right now, my base is sitting at 1.4. I did that just before I got on. I realized, oh, holy smokes, I didn't do it for 5 volts. But let me see if I can get this tuned up real quick. 0.42 milliamps, and so I want 2.5 divided by 0.42. 2.5 divided by 0.42. Let me try that again. 2.5 divided by 0.00042 equals 5.9K. Oh, wait, I want IC to be 1.26. So I want 2.5 divided by 0.00126 equals 1.9. So I need about 2K. Let me put that in, see if I can clean this thing up a little bit. My response right now, the collector is at the wrong voltage. Let me see if I can make an improvement here. Put on waveforms. Okay, where's my collector? 2K to VCC. I forget if this is the value I used when I did the simulation last week, a couple weeks ago. Well, that helps. Oh, that's pretty sweet. That's got my my collector right now. That's where I want it. I want it at 2.5 volts, but I don't have the gain. I need a gain of 10 out of this circuit. So let's see if I can do that. I don't know why I've been dinking around with it trying to fix this jitter. I don't know why it's so jittery today. I tried to put like capacitors. In fact, let me try that one more time. I'm going to put it just a capacitor across the supply from VCC to ground and see if it does anything for me. Whenever you like lay out a integrated circuit, one of the first things you do is when you lay out the chip on a printed circuit board, is you put a bunch of capacitors between the power supplies to ground just to filter any noise. It's not doing it for me. Okay, anyway. Oh, I think I got ahead of myself. One thing we want to look at real quick. The transistors you're using in your kit, I think, are the 2903, 2N3904 actually. The 2N3904 is what I have in my kit. If you have something different, it says it's an NPN transistor, small signal transistor. So if you have something different, just look it up and make sure you know where the base, emitter, and collector is. Right now on the board here, I have one of those 2N2222s, which is the old transistors that we use in the labs at the school. But it doesn't really matter. These ones will probably perform better. But you just here, you got your emitter is pin 1, if that's the flat side. And then the base is pin 2, and then the collector is pin 3. So you want to orient those on your board across 3 rows and then build it out from there. So I just want to cover that real quick. Now let's see if I can get some more gain out of this thing. Or let's see where my gain is right now. Put this over here. Come on. Come. Okay, and I want to set this over here to channel 2. I'll use the channel 2 scale. Oh, come on. Go back. I gotta always move 1 first. Okay. So this says I have 1 volt peak to peak on the output. And here I have basically 0.2 volts peak to peak. I set up my wave gen for 100 millivolts peak. And so it gives me 0.2 volts peak to peak. And so my gain right now is 1 divided by 0.2, which is equal to, it's actually, yeah, it's 1.079, I guess. Okay. So I've got a gain of 5 and my spec was 10. So let's look at that circuit again real quick. These are always in the way. I just bring that down. Oh, it was a Word document. Okay, so to get, so this was designed for 10 volts. So because of my kid, I have to go design it for 5-volt supply. So I recalculated this and I calculated that RC should be 200. Now, I'm sorry, 2000 ohms. Now, the one thing that's going on here though is I'm only getting half the gain that I want to out of this. And right now, I think I have 240 right here for REA. So I need to double that. But you know, when you build this, I think we saw this when we simulated last week too. We weren't necessarily getting, our gain wasn't necessarily RC over REA. What it really is RC parallel to the load resistor divided by REA, or something closer to that. And the reason that is, we've talked about this before, like a power supply has a lot of capacitors at the output to filter any noise. And so they can be essentially considered as a ground. So now essentially this node is at ground and this node is at ground. And so RC is in parallel with RL, the load. Okay, now I'm just going to do a hand calculation here. I've got a load of 4.7K, shift inverse, shift memory in, and then plus 2000 shift inverse equals shift inverse. Okay, so that says that effectively I've got a parallel combination of my load and my collector resistor is 1.4K. And so for a gain of 10, I want REA then to be 140. So right now I've got 240 in there. So let me find something close to 140. Looks like I have in my little resistor kit here. This isn't the one necessarily with the analog discovery. This is another one I have. I've got 120 ohms and I've got 150 ohms. I'll put in 150 and see if I can get my gain up to 10. Okay, let me swap that in real quick. Let's see, this is the first resistor of the emitter. Okay. Okay, let's see how I'm doing. It's always in the way. So I'm oscillating around 2. It went down since I changed my emitter resistor rather significantly. It was kind of at a sweet spot to have my collector at 2.5. But anyway, right now it looks like it's oscillating around 2 volts. That's where my collector appears to be right now. And so I have got 1.59. I'll call that 1.6 peak to peak, and then divided by 0.2. So 1.6 divided by 0.2 equals, I have a gain of 8. Okay, so on my circuit, I mean, there's 2 ways to work this. I always start by reducing the emitter resistor. And what we saw is when I reduce this, the collector voltage came down too. So because essentially there's more current going through here, and so I have a bigger voltage drop across there. Let me see. Right now at my collector, I have 2000. If I put a a larger resistor there. I'm going to put in a 2.2K and see if I can get this thing tuned up. 2000. Let me see if this will help bring my both the collector voltage up and then also increase my gain. This is going to BCC. Not sure if I got that in there well. Let's see what that looks like. Flattened out a bit, huh? That's because it dropped my average down. I don't like that. It's running into, this is basically my emitter voltage here. My emitter sitting like, it looks like just under, when it flattens out like that, I'm getting the bottom part of my dynamic range. So I think that was a bad move. I'm going to put 2K back there. And yeah, I'm going to put 2K back in there. And then I think I'm just going to reduce my emitter resistor again and see if I can do that, if I can get it a little more gain out of it. My gain was 10, and so it's got a spec of plus or minus 10 on it too. So I want to get at least 9. So right now in my emitter, I think I changed that to red, brown. What did I change that to? Oh, that's 150. Yeah, that's red, brown, green, red, brown, green, brown, 150. So I'm going to switch that now to 120 and see if that does it too for me. So I need brown, red. Let's see, brown, red. Where's my 120s? Brown. This might be it. It could be it. It looks more like brown, yellow, orange, brown. Let me give it a try. It's hard to see in the light what the color is. Well, it gave me a little more gain. Come on, grab. So my gain right now, it's oscillating around 2 volts. Ideally, it would be 2.5, halfway between the supply. Or actually, probably I'd have more dynamic range if it was even higher than that, like maybe oscillating around 3. But that's I'm not going to go recalculate that right now. So I've got a delta of 1.77 divided by 0.2. So I've got 8.85. So it looks like, let me see if I can just find 100 ohms. Brown, black, brown. Okay, let me put this in. Hopefully it doesn't pull down my collector voltage too much. I think my spec was I needed a 2 volts peak to peak. Yeah, I'm running into my negative supply. So this isn't optimum. But I think I've at least got my gain. I would have to tweak around with it some more to see if I can raise the collector voltage up. Yeah, I've got 2 volts divided by 0.2. So I do have my 2 volts peak to peak gain. Not ideal. Again, it would be better. I'd have to go I think through and recalculate. I think ideally I want the collector voltage sitting here like closer to 3. Maybe I can do that real quick. Hold on. Let's see. 1.26. I wanted 2 volts divided by 1.26 equals. Okay, I'm going to try to drop in a 1.5K. Yeah, 1.5K and see if that does it for me. I think I find one here. This is the big trick. To get a lot of the voltages, I had to put resistors in series. You can do them in series or parallel. Okay, that's a good improvement there. So what I did is I reduced my collector voltage, and in doing so, again, it's the collector current, the supply voltage minus the collector current times the collector resistor determines where the collector voltage is. So by reducing, I was sitting down there at 2, I reduced it from 2K to 1.5K. Now it's looking pretty good. It's oscillating around 2.5, which is a good spot to be. Okay. So anyway, as far as doing this lab and making your measurements, it says laboratory. I sat here, I had to dink around with it and tune it up. Part of the reason, again, is I didn't write down the values that I simulated last week. Hopefully you can start with your simulated values. And again, you can use, you might have to use resistors in parallel or series. Just try to get them as close as you can. What's always key, though, is getting the base voltage where you had designed it to be. Okay. So then step 8 of the testing this, it says check the collector current and bias voltages, and state whether the bias conditions are reasonably close to the design values. So we don't necessarily have to put an ammeter in series. I've got my little voltmeter here. I've got a little handheld one. You can use the one in the analog discovery too. To do that, actually, let's just do that. Let me think. Scope. I do this. Voltmeter. Run. So this tells me that my collector right now is at channel 2. My collector's on channel 2. It's at 2.4 volts. And then channel 1 is at the signal source. I'll move it over to the base. Okay, but I'm at 2.4 volts. I got a 5-volt supply. So my collector current is 5 minus 2.4 divided, and the resistor I put in there was 1.5K. That tells me that I wanted my collector current to be 1.26 milliamp. It looks like it's 1.73. Okay, and let's just for kicks see where my base is right now. Let me move that probe. That's the orange one here. So if I move it directly onto the base, that says I have my base is saying about 1.46. That's a good place for it. That's a good number, because that's basically tells me that the emitter's sitting at like about 0.8 volts, and then I've got a VBE drop of about 0.7, but 1.4 is a good spot. Okay, so anyway, you can use the voltmeter to measure the collector voltage, the base voltage, and then calculate the collector current by subtracting the collector voltage from the supply voltage and divide by the resistor. Okay, the next one, 9. Basically, step 10. Let's see. redesign the circuit at step 8, 9, 10 if needed to achieve the specification. So I already basically went through that when we started. I sat there and tweaked my collector resistor and my emitter resistor. And so again, what I think you want to approach, if you're not getting the gain you want, first, the first thing I would do is calculate the parallel resistance of the load and the collector, divide by the gain, and if your resistor is larger than that, then reduce it or modify that resistor accordingly for REA. So I think the first thing you do is you change the values of REA to try to get your gain where it is. And then if you find the collector is shifting downward or upward, then you might want to go in and consider changing the collector voltage value as well. Okay, so step 9, it says locate the mid-band range. Right now we are running at, let's see. Oh, we're only at 1 kilohertz. That's actually could be somewhat of a problem. We should actually probably be up around 10K. And the reason I say that is if our capacitors aren't large enough, we may not actually be in the pass band. Let me go back here and look at this again. So I got a little bit more gain out of that. It looks like here. Let me change the time base. Yeah, so actually there's a little more gain. We may not have fully been in the pass band, but if you're using 10 kilohertz and you're using like capacitors that are above 1 microfarad, you'll most likely be in the pass band. Okay, so that's still a gain of about 10, or that's within spec. Okay. And I'm also in there. Yeah, that's all okay. My amplitude, let's see. Look at wave gen here. Okay. I'm a little confused by this because right now it says my wave gen should be 100 millivolts peak. And then on the scope, it's 0.2 or 200 millivolts peak. So that's a little puzzling to me. And that changed. That wasn't like that before. I'm a little confused by that. It was definitely smaller before. Now I don't understand why that is. Okay. Well, anyway, just moving on. Okay, so what we want to do in step 11 is find the so step 9, basically run it at 10 kilohertz. You did your simulations last week, and I kind of recall that the high pass on the AC sweep was the dominant pole was the emitter capacitor, and it started its 3 dB point was in the 400 500 hertz range. So just if you're running at 10 kilohertz, you're going to be in the pass band. Step 10, I'll do step 10 before I do step 11. So step 10 says use a triangle waveform and find out where it starts clipping. Oops. Nope, I didn't do a triangle. There it is. Okay, so we're not clipping yet. So what I can do is I can increase my amplitude a little bit. The easiest thing to do is just bring it up a significant amount. And because we only have a 5-volt supply, it doesn't have, not going to have a tremendous dynamic range. So mine bottoms out, it looks like here, like around 0.9, but it hasn't clipped at the top. I'm going to bring that up even higher on wave gen. I'll put it at just 0.5 or 0.5 volts. Okay, so my dynamic range at my output is basically, I can go between 780 millivolts, which apparently is where my emitter is, and then 4.6 volts at the top end. So I can get a delta of like 3.8 volts peak to peak. So that's what we would call the dynamic range. And yeah, it's clipping harder. It's not necessarily symmetrical here. It's clipping harder on the positive end. But anyway, so that's basically step 10, defining where your peak to peak is. And it says compare the results with your specification. The specification didn't specify where the clipping occurs or anything. What you want to do though is you want to get your waveform. If it says that you need to have 2 volts peak to peak min, then just demonstrate and take a screenshot showing that you're with you're probably going to have to adjust your input voltage, but take a screenshot and demonstrate that you got 2 volts peak to peak. And again, look what I'm doing here on WaveGen. I'm not starting with 1 volt amplitude. I started with like 100 millivolts. And so this jitter bugs me. But anyway, I've got a nice clean waveform with 100 millivolts. And this is basically 100 millivolts peak is what it should be. I'm still kind of confused why the scale doesn't agree with the WaveGen. But essentially I've got like a gain of 19 divided by 10, 19.2. So it's a little bit over 8 or a little bit over 9.5. Okay. So anyway, finally, step 11, it says, do a frequency sweep and find the lower minus 3 dB frequency. So we want to find out where the amplifier's high pass, it's on the low end, but it's a high pass, where that occurs. And so where it essentially turns on or where it gets into its pass band. Okay, so I've got 1.92 peak to peak. And I'm going to multiply that times 0.707. And that takes me to 1.35. So when my peak to peak voltage is 1.35, I'll be approximately at the 3 dB point. So I'll go back here to WaveGen. I'm going to just reduce this to 1K and let's see what that looks like. I got to change my time base here. 200. Okay. So I still pretty much have the full amplitude. Again, I'm looking for 1.35. So let me go to WaveGen 2. I was at 1 kilohertz. Let's see what 500 hertz looks like. Let's see. 500 hertz. Yeah. So I lost a little bit of amplitude. Let's adjust this. I wish it wasn't so jittery. Let's see. Maybe I can do something to help that. Wrong way. Trigger, rising, falling, either. That didn't help. The oscilloscopes at the university have like filters that you can actually put on the trigger and the channels. Not sure. I forget if I have that capability here. Anyway, I'm at 1.48, so I'm getting close. I'm looking for 1.35. I'm going to move this down a smidgen. I'm going to go to 400. Let's make a minor adjustment here. So that's 1.31. I mean, you can sit there and dink around with the placement of the bars, but that's essentially where its 3 dB point is somewhere close to 400 hertz. So yeah, capture that and then compare it in your, go back and look at what your SPICE told you and see if there's any correlation. Comment if they agree or not. Okay, so that's basically the testing you're going to do. So what I want you to do then again, and just to repeat myself, is at the end of your report, you should have the final circuit that you build with all the components. If it's different than what you simulated, maybe comment on why it's different. Maybe like you had to still change REA to increase the gain. to get it within your spec. But the specs have a value for peak to peak voltage, minimum peak to peak, comment and show a display, oscilloscope display that you met that. And then comment on the gain that you met your gain spec. And then they also gives you a resistance spec, although it didn't ask us to measure it. So that's okay. But otherwise, in the SPICE simulations, we did a measurement. And you can comment on that as to how accurate SPICE told you your impedance was, your input impedance. Okay, it says present the final design in a form of a schematic diagram with all parts labeled, the one that you built. State the specifications for gain and output voltage swing along with the given specifications, and state the collector current and the value of VBB. I would compare the collector voltage, the collector the base voltage, and the collector current to what you simulated in SPICE. So at the end, make a table, show what gain you got in SPICE, show what voltage peak to peak you got in SPICE, or list that in the table, and then comment on the DC parameters. And then in another column, record what you measured. That's basically it. When I go to grade, I'm basically going to look at you got the simulations there, you got the scope plots that you built it, and then a summary table. And that's basically it. Okay. This next question, it says, justify your amplifier circuit has bias stability against variations of beta and in temperature. That one, I'm drawing a blank right now. I know that we've answered that before. For the temperature, I mean, what you would do is, if I was in a lab building a circuit, what I'd do is we basically have heat guns or essentially a hair dryer. If you blow that on your circuit and the amplitude doesn't change significantly, then you know that it's got some stability against temperature variations. And then the beta, I don't know. I'm drawing a blank on that right now. Do some creative writing for item 2 as to why. I know I've answered that in the past, and I just can't recall how to approach that. But anyway, not a big deal. What I'm mostly looking for is basically a summary table at the end. And actually, we had to do some changes on my circuit to get the gain. You may find it much better. I think again, the transistor I'm using right now is rather old and doesn't perform as well as the ones you have in your kit. You may have much better current gain and a much better beta in the one in your kit. So you might not have to dink around so much to get your gain within spec as I had to do here. Okay, that's about it. My demonstration, I'm a little embarrassed that it's so jittery and wasn't so I had to play around with it a while just to get something that was reasonable, but it's basically working. Any questions, or are you guys confident you can go ahead and build this? Okay, we're almost done. If there's no questions, I'll end this and you can go off and try to build. And during the week, if you're building it, it's just not working for you, take a picture of the circuit. I can probably figure out, but maybe label where the emitter base collector is on it and which probes are which. And you can send that to me in email. I might be able to help you troubleshoot it. And if you do that, also just send a picture of your schematic. And what what's going on in your waveform too. You know, again, what I'm looking for on mine is ideally this thing's going to be oscillating between, like, it's going to be right in on a DC offset of either 2.5 or 3 volts. And that'll give you the most dynamic range. So you want that's basically your collector voltage there. And then your base should probably be somewhere in the order of like 1.3 volts to 1.6 volts, somewhere in there, for this thing to operate well. And so those are the first two things to check. If your circuit isn't working, try to figure out if your base voltage isn't where you thought it should be, or your collector voltage isn't where you thought it should be. Try to figure out what's going on in those two places. That's a good place to start. The collector voltage is always a good place to start. Okay, so I'm just rambling now. Any questions, or shall we sign it out? Oh, we got some questions on the chat. This is our last meeting. Yes. If we have questions, if we have trouble on Lab 8, what's the best way to reach you? I don't look at my CSUS email every day, but there's one on the syllabus called J. I'm sorry, drawing a blank. j.quilici1@sbcglobal.net. So that's on the syllabus. I look at that one every day. That's my oldest email. Can we come to my physical class? Yes, I thought last night was going to be the last night, but I have to go back again next week for some of my students who didn't finish. So my physical class is Wednesdays at 6 p.m. in room 517. And so I do plan to show up there next week and help. I know I probably will have like 2, if not 3 students in there. So yeah, I will be in the Riverside 517 next week at 6 o'clock. And usually that session goes from 6 to 8:45. But anyway, and that's Wednesday. Yep. Okay, I think we're done for tonight. And if not, if you're having trouble, first thing you can try is send me some pictures on email. And then the second thing, if you can show up next Wednesday at the lab. Okay, thank you, everybody.